The B-52 bomber first flew in 1952. 7 decades later, it's still the backbone of America's long-range strike force, and now it's about to get the most advanced engines in the world. Rolls-Royce's F130 power plants promise 40% better fuel efficiency, 17,000 pounds of thrust, and decades of reliable service, all packed into an airframe that was designed when Eisenhower was president. If that sounds insane, it is. This 70-year-old jet is being transformed into the B-52J, and the upgrade could change far more than just military aviation. But before we talk about what the new engines can do, you need to understand why the old ones nearly grounded the entire fleet. The need for new engines. If you only looked at the outside, you would think the B-52 still had plenty of fight left in it. Big, intimidating, and heavy enough to carry half a small town's worth of weapons. But the real story isn't in the wings or the fuselage. It's in the engines. And that story is ugly. Those 8 power plants strapped under the wings are relics from the early 1960s. At the time, they were cutting edge. Today, they are antiques. Imagine running a war machine on engines that burn through fuel faster than anything else in the sky, break down constantly, and rely on spare parts that don't even exist anymore. That's exactly where the Air Force has been stuck. The cost of keeping them alive has exploded. We are talking tens of millions of dollars each year just to make sure the jets can even take off. And when parts dry up, mechanics are forced to get creative. They have been scavenging from old stockpiles, cobbling together fixes, even using emergency methods that should have been retired with the Cold War. One of them was blasting a small explosive cartridge just to start the engine. It's noisy, unreliable, and frankly, embarrassing for an aircraft that is supposed to represent American power. But maintenance bills and headaches are only half the issue. The other half is performance. These engines drink fuel like there is no tomorrow, slashing the bomber's range and putting constant pressure on refueling operations. Every long mission becomes a logistical circus, with tankers lined up just to keep this long-range bomber actually flying long-range. And let's not forget the noise. These engines roar across the sky, making the B-52 impossible to hide. For a jet that sometimes has to operate in sensitive areas or near hostile borders, that's a serious liability. And then there is the danger nobody wants to talk about. These engines are decades past their intended lifespan. Every flight carries the risk of something going catastrophically wrong. That's not acceptable when the B-52 is still central to America's nuclear and conventional strike plans. By the 2000s, sticking with the old engines wasn't just inefficient, it was reckless. The Air Force didn't have the luxury of waiting anymore. It wasn't about giving the B-52 a performance boost. It was about keeping the jet alive at all. Without new engines, the bomber fleet was headed for an early grave. Now they knew the old engines were pushing the bomber toward an early grave. The question was never if they had to be replaced. The question was, with what? Rolls-Royce F130. The Air Force had to find something strong enough, efficient enough, and reliable enough to keep a 70-year-old bomber in the sky for another 3 decades. That's where Rolls-Royce stepped in with a plan that sounded ambitious, maybe even impossible: the F130. Now don't mistake this for a quick copy and paste job from the commercial market. Yes, the F-130 comes from the same family as engines already powering sleek business jets, but this version has been custom-built to deal with the quirks of an airframe designed when Eisenhower was still in office. You cannot just bolt modern power plants onto a Cold War bomber and hope for the best. Every piece has to be engineered for a machine that was never meant to live this long. And yet, that's exactly what Rolls-Royce has pulled off. The most obvious change starts with fuel efficiency. For decades, the B-52's old TF-33 engines guzzled fuel like nothing else in the sky. Every long-range mission turned into a logistical circus, with tanker aircraft constantly on call just to keep the bomber moving. The F-130 promises up to 40% better fuel economy, and that figure is not some marketing spin. In the world of heavy aviation, those numbers change everything. Less fuel burn means longer missions without stopping, fewer refueling operations that put crews at risk, and a massive cut in operating costs over the bomber's remaining life. For an aircraft expected to keep flying into the 20s, this isn't just nice to have. It's survival insurance. Then comes reliability. The old engines were maintenance nightmares, fragile machines that needed constant attention. Crews would spend more time babysitting them than actually flying. The F-130 has been designed with durability in mind, with service lives measured not in frantic patchwork repairs but in decades of dependable performance. Fewer overhauls, more predictable schedules, and dramatically less downtime mean that the bomber can stay mission-ready instead of being grounded while technicians scramble for parts that don't exist anymore. For an aircraft that still forms the backbone of America's bomber fleet, that kind of reliability is priceless. But efficiency and reliability are not the only cards on the table. The F130 is also bringing raw power. Each engine can generate around 17,000 pounds of thrust, compared to the 12,000 the TF-33s once managed. That extra muscle changes the game in ways that matter. It means easier takeoffs, stronger climbs, and better high-altitude performance, especially in hot or thin air environments where the old engines struggled. More thrust also means more payload capability, something no military is ever going to complain about. Of course, promises don't mean much until the engines prove themselves. That's why one of the biggest milestones came at NASA's Stennis Space Center, where Rolls-Royce tested a twin pod with two F-130s mounted side by side to mimic the real setup on the bomber. The test was a success, showing that the engines could not only run individually, but work together as a system, just as they will have to do in combat conditions. The next hurdle is even tougher: altitude trials at the Arnold Engineering Development Complex, scheduled to push the engines into simulated real-world extremes. Thin air, scorching heat, freezing cold, it's all on the checklist, and if the F-130 can handle that, it won't just be certified for service, it will be battle-proven before it ever takes to the skies on a B-52. Now this is where the story takes an unexpected turn. The F-130 might be designed for a bomber, but its DNA comes from a commercial line, the BR-725, and the broader Pearl engine family. Those engines already power luxury jets like the Gulfstream G700, which means the technology isn't some experimental gamble. It's proven, refined, and trusted in civilian skies. The military version has been toughened up, adapted for the unique stress of bomber duty, but the core lessons flow both ways. The Air Force gets a modern, efficient engine, and civilian aviation gets a front-row seat to innovations that could spill over into future passenger fleets. Think about what makes this relevant to airlines. You have an engine compact enough to fit on an old bomber, but powerful enough to push out 17,000 pounds of thrust. You have fuel burn efficiency that meets modern environmental standards, something every commercial carrier is under pressure to achieve. And you have advanced materials that allow the engine to run hotter and longer without breaking down, which translates directly into fewer inspections and lower maintenance costs. Every airline on the planet wants exactly those things, and Rolls-Royce is proving them in one of the toughest testing grounds imaginable. The F-130 is also packed with digital smarts. Its FADEC system, which is full authority digital engine control, gives precise control over fuel flow, thrust, and efficiency in real time. These systems are standard on modern airliners, but adapting them for the B-52 wasn't simple. Engineers had to rewire, rethink, and redesign around a platform that never anticipated digital integration. Out of that challenge came new solutions. Solutions that can flow right back into the commercial market. It's a feedback loop where the military's needs drive breakthroughs that airlines can then adopt to cut costs and boost reliability. And make no mistake, this is not just about engines. Once the upgrade is complete, the bomber will be redesignated as the B-52J, marking it as a fundamentally new system rather than just a patched-up relic. Along with the F-130s, the aircraft is getting a modern AESA radar system, giving it sharper targeting, stronger tracking, and resilience against electronic warfare. The cockpit and backbone of the bomber are being digitized, with new computers, communication links, and mission systems that will plug it directly into the modern battle network. A jet that once relied on analog dials will now be able to share targeting data in real time with stealth fighters, satellites, and ground forces. But there is a catch. None of this is simple. The B-52's design dates back to the 1950s, which means every new engine mount, every wire, every support beam has to be analyzed and re-engineered for safety. This is not plug and play. Boeing and Rolls-Royce are leaning on advanced digital modeling, building virtual twins of the bomber to test stress points, airflow, and integration long before the real hardware goes in. It's cutting-edge simulation being applied to one of the oldest active aircraft in the world. And even with that, the timeline has already slipped. Initial operational capability was once expected by 2030, but the date has now been pushed to 2033. The Government Accountability Office pointed to underestimated complexity, especially in wiring and structural integration. In plain words, it's harder than they thought. Still, the project is moving forward because the alternative is not acceptable. To make it work, the Air Force also needed a production pipeline it could trust. That's why every F-130 is being built in Indianapolis, at Rolls-Royce's largest facility in the United States. Over 600 engines are on order, backed by a $600 million investment to modernize the plant with new automation, precision tooling, and testing bays. The economic impact is enormous here. More than 1,000 direct jobs at the facility, plus a supply chain of American companies feeding parts and materials into the program. And since the engines will need decades of upgrades, maintenance, and software updates, this is not just a short-term boost, it's long-term industrial momentum. And while this is an American project, the world is watching. For other countries struggling with aging fleets, the B-52J upgrade offers a model. Don't scrap what works, modernize it. Full replacement programs cost billions, take decades, and are magnets for political battles. Retrofitting with modern engines and systems can keep proven airframes flying at a fraction of the cost. Add in the growing emphasis on sustainability, and the case becomes even stronger. Why melt down usable jets when you can give them new life with engines that cut emissions and stretch range? That's the irony. A bomber born in the early years of the nuclear age might end up shaping the next generation of both military and civilian aviation. Rolls-Royce's F130 proves modernization doesn't always require a blank sheet of paper. Sometimes the smarter move is to take what already works and make it better, stronger, and more efficient. And if this old warbird can do it, imagine what comes next. And the part that turns heads outside of aviation is that this isn't only about military power. It's about money, jobs, and influence. The moment the contract was signed, the F130 program stopped being just an Air Force project and became a massive industrial engine in its own right. Ripple effects. Rolls-Royce didn't pick Indianapolis by accident. This plant is now the heart of production, with over 600 engines on order and hundreds already moving through the pipeline. That translates directly into American jobs. More than 1,000 workers, including engineers, machinists, and technicians, are tied to this program, and that number only grows when you follow the supply chain. Small and mid-sized companies across the country are building components, processing raw materials, and supplying the parts that make the F-130 possible. Every engine rolling off the line is proof that defense dollars don't just disappear into the Pentagon, they ripple out through local economies. But the story doesn't stop at initial production. These engines are not disposable. They will be maintained, tracked, and upgraded for decades. That means stable, long-term work for the same facilities and workers building them today. Software updates, predictive maintenance, performance checks. It's an entire cycle of sustainment that keeps thousands of Americans employed long after the headlines move on. For lawmakers, that's the sweet spot. A defense program that strengthens national security while pumping steady investment into domestic industry. And let's be blunt, this is also a political win. In an era where outsourcing is often criticized, this is a program that keeps advanced aerospace manufacturing inside U.S. borders. It's not just about national pride, it's about practical control. Producing engines in Indianapolis means the Air Force is not waiting on overseas suppliers or juggling fragile logistics chains. Timelines stay tighter, costs stay closer to the plan, and accountability remains domestic. For decision makers in Washington, that's worth every penny. For Rolls-Royce, the benefits stretch even further. Landing this contract cements its role as a trusted supplier inside U.S. military procurement, a market every aerospace giant wants a piece of. And beyond the prestige, it's a showcase. The F-130 proves Rolls-Royce can take civilian technology, adapt it for extreme military use, and deliver results at scale. That reputation matters because it feeds directly into the company's position in the global commercial engine race. In other words, this bomber program is doubling as a billboard for Rolls-Royce innovation, and don't think the world is not watching. What began as a U.S. Air Force solution has turned into a proof of concept for militaries everywhere. If an aircraft designed in the 1950s can stay operational with targeted upgrades, what does that mean for all the other aging fleets out there? Surveillance planes, patrol aircraft, transport jets. Many countries are now asking the same question. Is modernization smarter than replacement? The answer looks obvious. New programs are expensive, politically sensitive, and almost always delayed. Retrofitting, on the other hand, extends life, boosts capability, and cuts costs. The B-52J is also fueling a shift in strategy. For decades, the conversation around defense modernization was about brand new platforms. Now, sustainability is part of the discussion. Why scrap usable airframes when you can make them cleaner, quieter, and more efficient? Modern engines like the F-130 cut emissions, reduce fuel burn, and extend range, all while giving new life to old platforms. That combination of efficiency and capability is hard to ignore. And it's not just about the United States. For allies and even rivals, the B-52J is proof that military modernization doesn't always require starting from zero. You can take a proven design, bolt on smarter technology, and create something entirely new from the bones of the old. The U.S. Air Force plans to fly the B-52J alongside the stealthy B-21 Raider, splitting missions between raw endurance and deep penetration stealth. Together, They will form a 1-2 punch that covers every strategic need without forcing the Pentagon to spend trillions on an entirely new fleet. Other nations with tighter budgets are paying attention because that model saves time, money, and resources. And the crossover potential goes even further. Engine makers, airlines, and foreign governments are already studying the F-130 closely. This is a technology story with global reach. Civilian aviation wants engines that last longer, burn less, and make less noise. If a 70-year-old bomber can be transformed into a modern, fuel-efficient workhorse, the lessons learned could end up reshaping commercial fleets too. Now tell us, what do you think is more powerful, building new jets or upgrading the ones we already have? Share your opinion in the comment section below. And before you go, don't forget to hit that subscribe button so you never miss the latest aviation updates. We will keep you in the loop. Goodbye for now.